We are going to do polymerisation. Okay, let us concentrate on the most important part on which most students get problem. Okay, let us see polyester and polyamide. Okay, now what about polyester? Polyester, let us do it like that. Polyester, we should have ester linkage. So ester linkage is like that. This is ester linkage. You remember in theory how we get an ester? How we get an ester? You remember, for example, we take ethanol, ethanoic acid and methanol. Now, what is the formula here? It is CH3COOH. What is the formula here? It is CH3OH. So we put the CH3 in front, then we put the OH here. Then each one will retain an oxygen. So this will retain an oxygen and this will retain an oxygen. So what will be removed is water minus H2. Okay. Now what is formed here? It is CH3CO. Put this here. This is eliminated. Then we put the O, CH3 here. Now this is an ester and this is the ester linkage. Okay, this is the displayed formula. We have displayed all the bonds here. We have just written it like that. Now, what about what will happen now? What is the name of this? Now, the ethanol, the alcohol, you remove the ol, you add methyl. You add YL. You remove the ol. In the alcohol, you put Y. So it is methyl. Now, you remove the ic. You add ATA. It is ethanoate. Ethanoate. I'm explaining things to students who try to use logics in the examination. Okay. So this is how we do an ester. Okay. Let's do another ester. Let's do butanoic acid. Butanoic acid. And then we do propanol. Okay, first we write the formula of butanoic acid. You know butanoic acid, we have 1, 2, 3, 4 methane, ethane, propane, butane. You know this. You know methane, ethane, the second one. The third one is propane. The fourth one is butane. Now these are 1 carbon, 2 carbon, 3 carbon, 4 carbon. So butanoic acid will have 4 carbon. So we put the 4 carbon here. Okay, now here we put the COOH. Now here it is CH2. CH2, the last one is CH3. So this is butanoic acid. If you don't know how to write butanoic acid. Now propanol. We have 1, 2, 3 propanol. Propane has 3 carbon. So you put 3 carbon. 1, 2, 3. You put the OH in the back here. So you remain with this. You remain with this. And here we will remain with this. So let us write it clearly now. CH3, CH2, CH2, COOH. Now we have OH, CH2, CH2, CH3. Now this is propanol and this is butanoic acid. Now each one will retain an O. So this will be remove H2O. This we call hydrolysis. Hydrolysis. Hydrolysis means removing of oxygen. No, condensation. This is condensation, sorry. This is condensation. I do a mistake here. This is condensation. Okay, we are removing water here. So what is happening here? When we are breaking a bond, like we are breaking this, we are breaking the ester linkage. This is hydrolysis. But when we are the ester linkage being formed, this is condensation, removal of small molecules. So what will happen here? You will get this. So what is happening here? You put this here, then you bring this close to this. So this is the molecule. Now what is the name of this? The name of this is, as I told you, in the alcohol you remove Y, you remove anol, you add YL. Now in propanol we remove anol, we put YL, so it becomes propyl. Now, as I told you, in the acid, you remove IC, you put ATE. So we remove IC, we put ATE, it butanoate, become butanoate. So this is a revision on ester. This is ester linkage. Now, let us do polyester. Now, what about polyester now? You put a small square like that, then you put COOH, then you put COOH. It's always like that. Now an alcohol, therefore we put OH. As I told you, each one will retain an O, so water will be removed here. Here also water will be removed, and here also water will be removed. So each one retain an O. So here water will be removed. Okay, now this one will become close to each other. So it becomes CO. You bring this here. Now, very easy to continue. You just make a mirror line here. You just reflect it. So if a mirror line is here, a mirror line, put a mirror line here. Just reflect this part. O becomes here, O becomes here, C becomes here, then the square becomes here. Now how to continue this? You put a mirror line here, you just reflect this on the other side, become C, O, like that. Then you continue like that. You may put a mirror line here, you just reflect this. O, C, like that. Okay, now if you are told to find the repeated unit, these are the monomers. Okay, the monomer is this acid and this alcohol. Okay, these are the monomers, and if you are told to give a repeated unit of the polyester, this is a polyester. So you just have to bring it here. You cut this here on your computer, then you paste it. Now don't repeat this one. We have already a triangle here. We don't put this triangle, so we stop it here. So this will be our repeated unit. This will be our repeated unit. Voila. Okay, how it is easy? Because what is repeated unit? If you copy this in your computer, then we add it. We copy this, we add it, we continue to add it. It will become the long polyester. Now we put N here. What does N represent? We have a lot of this. We put 3 small dot here and 3 small dot here because it will continue here and continue here. Okay. This is our polyester, and this is the ester linkage. Okay, now let us do polyamide. In polyamide, we have this, NH. This is a peptide bond. Peptide bond, or we call it peptide linkage. So how it is formed now? I put my page like that so that I have more space. You put again your COOH like in polyester. But this time you don't put OH, you put NH. Okay, now water will be removed, H2O. Therefore, this will be removed, minus water. So what we'll get? The small square here, CO bond NH bond this, and this will continue. Now you have the peptide linkage between the two. How to continue this? You just put a reflection here. It become NH OC square here. Here you just reflect what is found here on the other side. It becomes CO bond NH bond triangle, and this continue like that. So this is now if you have to find the repeated unit, you just cut it near the triangle here, and then don't put triangle again. Don't put triangle again, so you put it here. So our repeated unit will be, put 3 points here, like that. OC, CO, NH bond, 3 points here, then you put N here. So this is your repeated unit in your polyamide. Okay. Now this is your repeated unit in polyamide. These are the monomers. The monomers are small square COOH, and NH2 on that side, NH2 on that side. Okay. Now, if tomorrow the examiner wants you to do a to use the monomer here, we have here, and then we have COH on that side and NH2 on that side, like amino acid in a protein. These also will be added. Okay, then you can continue. Okay, now this is a polyester. This is an explanation of how esters are formed, so that you have a better understanding of what is ester linkage. And these reactions are condensation reaction, because they are not addition reaction. Now, what is addition reaction? So what is condensation reaction? It is a reaction where monomers are added up, okay, and with the elimination of small molecules like water or HCl. Elimination of small molecules when bonds are formed, okay, when monomers are added to form polymers, okay, and this is condensation. And now addition reaction, it's very simple. If you take a molecule having double bond here, suppose we have CH3 here, we have Cl here, we have H here. You have to add it. You break one of the bond and you put it on either side of the molecule. Very easy, no? You break one of the bond, you put it one on that side, one on that side, and then you keep on adding. So this will be Cl. Here we have 2 repeated units. So examination, if you are told to find 2p repeated units, you just do it like that. This is an addition reaction. Okay, this is non-biodegradable, non-biodegradable, because microorganisms are not able to break the bonds here. But if you have a polyester or a plastic made up of polyester ester linkage, these can be broken by microorganism. Okay, if you have amide linkage or peptide linkage, these can be broken by microorganism by means of enzyme action. But these cannot be broken down, so they are pollutant. Okay, these are very simple structures that you will get. This is PVC. Okay, the plastic pipe in our kitchen and bathroom. These are the PVC that are used. Okay. Now this is polyester. This is polyester. Now you should remember this. This is the monomer, and no, this is the monomer. No. This is the monomer, and this is the monomer. For the monomer is square COOH, and triangle OH and OH. Now, what about the triangle and the square? The square is a very complex molecule. Okay, it contains many carbon, hydrogen, things like that. But we are not interested in this. We are not interested in knowing this is a symbol. This is a symbol representing a complex molecule. Okay, it is a diagram. For example, this is a girl. This is a diagram to represent a girl. Have you ever seen a girl like that? No. This is a symbol. So this is also a symbol representing a very complex molecule. To avoid confusion, we represent this like that. Okay. Now we have different types of this and different types of this. This to distinguish between the two. Now in polyamide, it is like that. It's in polyamide. Okay, this is in polyamide. So in polyamide, very important to remember, we have COH on one side, COH on one side, and H2 and H2 on one side. H2O remove, so peptide linkage is formed. So as usual, you put a mirror line here, then we reflect on the other side. You put a mirror line here, you reflect on the other side. Here also, after having formed the bond, you put a mirror line, then you reflect. So easy, okay? So easy. So easy. Okay? Now, in our next video, we are going to give more details about polymerization, like natural polymerization, and some more example in the examination questions. See my next video in polymerization. Okay, I will name this polymerization 1. Then you can see polymerization 2 because the video will be too long. Okay, now enjoy chemistry. Bye-bye.